Hey guys, Miss Seifert again. I'm here with a quick review about minerals and rocks. We've done most of this spring, so it should be fairly familiar to you, but you've also been talking about it for many years, so none of this should be too big of a surprise. First of all, minerals. In order for something to qualify as a mineral, it must meet these qualifications. It must be naturally occurring, it must be inorganic, it must be a solid in its natural state, it must have an actual chemical composition, and a definite crystal structure. So anything that does not meet these qualifications is not a mineral. And a mineral is consistent all the way through, which is how we end up with that actual chemical composition and that definite crystal structure. Okay, minerals can be identified in a variety of ways, and we're going to need to use many times most of these tests in order to identify the mineral. So the first way is color. But color is not very accurate all the time. A lot of minerals are the same color or very similar colors, or may even come in multiple colors. So we typically don't rely on color in and of itself. Obvious example here is pyrite or fool's gold. That is an iron pyrite. It's not really gold, but it's the same color as gold. So it tends to trick people into thinking it's gold. Hardness. Hardness is really a good example. Mohs hardness scale is a great way to test minerals. So things like talc and gypsum, they can easily be scratched by a fingernail. Calcite can be scratched with a copper coin. Fluorite and apatite can be scratched with a steel knife or glass. Microcline can also be scratched with a steel tool. Quartz, topaz, corundum, and diamond, these can be scratched by anything with more hardness. Okay, so corundum and diamond can both scratch topaz. Diamond can scratch corundum. Diamond can only be scratched by other diamonds. So making sure that you look at and understand the Mohs hardness scale, which is in your packet, is going to be really important. Streak, to test for streak, we actually take a mineral and rub it across a piece of porcelain, and it leaves behind its powdered version or its true color. So in that case, what's really interesting is that if you take real gold and you scratch it across a porcelain plate, you're going to have a gold streak left behind it. If, on the other hand, you streak fool's gold across a piece of porcelain, you're going to end up with a black streak left behind. So that's often a good way to tell whether something is fool's gold or real gold. Okay, cleavage and fracture. If something breaks into nice even lines, then we call that cleavage. Okay, mica is a fantastic example because it goes in very thin sheets. Fracture, on the other hand, means it breaks off in all different directions and you don't have those nice flat planes. Luster is how it reflects light. So it could be metallic, it could look soapy, it could look rather dull. Magnetic, only a few things are magnetic. And smell, we do have a few things that actually release a smell, sulfur being one of them. There's some key minerals identified in your packet. Probably need to know what those are. Quartz and micas and a few others. So make sure you take a look in your packet at those key minerals. Okay, moving on, we have the rock cycle. And we tend to think of this as fairly simple, but it can also be pretty complicated. It's not always in the exact same order. So we have igneous rocks, which can get eroded into sediments, which can be put under a lot of pressure and cementation to form sedimentary rock. That can be subjected to heat and pressure to form metamorphic, and metamorphic rock can be heated and eventually melt back into magma, where it can erupt again and cool and form more igneous rock. So you can have this, but you know what? Sedimentary rock can be eroded and can create new sediments, which can create new sedimentary rock. Metamorphic rock can be eroded to create new sediments, which can also become new sedimentary rock. Okay, sedimentary rock can also be melted and end up being magma and then form new igneous rocks. Igneous rocks can be put under heat and pressure to form metamorphic rocks. So this can go in any different directions, but you need to understand that the three main types of rocks are igneous, sedimentary, and metamorphic, and the materials that these can turn into are either magma or sediments. Okay, so igneous rock, this was formed through the cooling of magma and lava. Magma is underneath the surface, and lava is once it's reached the surface. So that's kind of how we break down the rocks anyway. Extrusive means that it was formed from lava, that magma made it to the surface, became lava, and that's when it ended up cooling. You get very small or fine-grained crystals. In some case, in the case of obsidian, we often say that it has no crystals whatsoever. It's volcanic glass. So pumice is the one we talked about that you might see when you're getting a pedicure. They actually use pumice to exfoliate the skin, and that actually has little holes in it. Those were bubbles. This lava cooled so fast that the bubbles didn't even escape. Obsidian being that glass, or basalt, which forms on the ocean floor. Intrusive rocks are ones that cooled while they were still inside the earth. They never became lava. So it's magma that has cooled underneath the earth. We get larger crystals because it cooled slowly. And in cooling slowly, it allowed more time for those minerals to kind of clump together. So coarse grained, this is going to be granite. Granite's a great example of an igneous intrusive rock. Okay, sedimentary rock. What happened was rocks were weathered. Okay, they were broken down into pieces. They were eroded or moved elsewhere, and then they were deposited somewhere else. But then they get compacted and cemented. And compaction is pressing them together, cementing is gluing them together. So we've got several different types. We've got clastic rock like breccia and conglomerate. Breccia has very sharp shards. It's like broken pottery. Conglomerate is going to be, which actually that should be spelled with an A, conglomerate is going to be rounded edges like pebbles and things that have been squashed together into a sedimentary rock. You can have organic sedimentary rocks. Now remember, these don't qualify as minerals because minerals have to be inorganic, but they are in fact rocks. Okay, so you can have chalk or coal, both of which come from the remains of ancient living things. Okay, and you can have chemical. Chemical rock would be halite, rock salt. Limestone actually should be classified as organic, so that looks like that one's out of order on my presentation. I apologize for that. But rock salt or halite is where the water evaporated and left behind the salt, and that would be a chemical sedimentary rock. Okay, moving on, metamorphic rock. To go through metamorphosis means to go through a change. These are rocks that have been subjected to a lot of heat and pressure and therefore have changed from their original. Okay, they're split into two types. Foliated means it has bands in it. Unfoliated means it's unbanded. Okay, so schist, gneiss, slate, marble, quartzite, all of these are going to be metamorphic rock. Metamorphism, this happens with contact with heat. Okay, so when you've got magma that comes through other rock layers, what it does is it actually changes the rock immediately around it because there's so much heat as it comes through. Okay, you can also get regional or fold from high pressure colliding tectonic plates. So whenever we start to see metamorphic rocks, that tells us that that area at some point went through a lot of heat and pressure from either folds or other tectonic movement. Okay, so real quick, an overview of the whole thing. First and foremost, you've got molten rock. If it's above ground, we call it lava. Underground, we call it magma. When that cools, it forms igneous rock. And we classify that igneous rock based on whether it cooled underground, intrusive, inside, like granite, or whether it cooled outside, extrusive. So that would be basalt. Again, the ocean floor is primarily basalt. You've got pumice, which actually has those little holes in it where the bubbles didn't even have time to get out before it cooled. And you've got obsidian, which is volcanic glass, and it has basically no grains. So big grains on intrusive, very small grains or no grains on extrusive. Rock can be weathered, and it can go through physical weathering where it's broken down, but it remains the same thing. Like ice wedging, you might have a rock that just breaks off the cliffside. Okay, fundamentally, when physical weathering happens, the pieces of rock are the same type as the rock they came from. With chemical weathering, however, it actually undergoes a change. So if you have a rock with iron in it, it can actually rust as a result of exposure to water and oxygen, right? The other one would be limestone dissolving, and that ends up being a different type of rock than it was when it was still in the limestone. Okay, so once it's been weathered or broken, it ends up getting moved through erosion. Remember, wind, water, ice, and gravity being our primary ones, and then it gets deposited somewhere else. That is sediment, and that sediment can be compacted or pressed together, and then it can be cemented or glued. That forms a sedimentary rock, and our sedimentary rocks can be clastic, Okay, and that means that they're pieces that are clinging together. They have been glued together. So sandstone, shale, conglomerate, all of these are clastic sedimentary rocks or non-clastic. So you've got ones like limestone, ancient coral reefs, halite, which is that rock salt that where you've had evaporation, and coal, which is remains of ancient swamps or plants that were in shallow water. Okay, subjected to heat and pressure, you can end up with metamorphic rocks, and we classify metamorphic rocks on whether or not they have bands. So non-foliated does not have bands. Marble is a good example, as is quartzite. Ones that do have bands are called foliated. That's gneiss or schist. Okay, and of course this can all be melted to form new molten rock, magma, and lava. Okay, so remember our rock cycle is really important. And you need to know those three key rocks as well as the types of things they can become, either magma or sediments. Okay, soil profile, remember that all soil is created from broken down bedrock. And over time, we eventually get a full soil profile. Level A, horizon A, ends up with the most humus or broken down living things. So this provides a lot of food for new plants and a lot of growth to happen. Below that, in the B horizon, we end up with very little humus. It's a subsoil. You might see a few roots down here, but that's going to be about it. It does have minerals that have leached down from the top into the subsoil. Down at level C, at C horizon, you've got weathered rock. Okay, so you've just got broken up pieces of bedrock. And of course, below that in horizon D, we're going to have the bedrock of the area. So that's it on minerals and rocks, and I hope this was helpful.